In this video, we learn how to work with the z-scores. The z-score is defined as the number of standard deviations that an observation falls from the mean. The z-score is computed using the formula the observation minus the mean divided by the standard deviation. So this is a two-step process. You first subtract the mean and then you divide by the standard deviation. From the formula, we can actually learn a few things. If the observation is equal to the mean, then the z-score is 0. If the observation is smaller than the mean, then the z-score is negative. And if the observation is larger than the mean, then this results in a positive z-score. The z-score can be used to detect outliers, and it can also be used to compare measurements taken on different scales. In example 1, men have a mean height of 69.3 inches with a standard deviation of 2.8 inches. I am 75 inches tall. Is this unusually tall? So the first step would be to compute the z-score. So the z-score would be the observation of 75 inches minus the mean of 69.3 inches divided by the standard deviation of 2.8 inches. And you can do the subtraction and the division, and we come out with a z-score of 2.03. So it turns out that I am about 2 standard deviations above the average height. This would not be considered an outlier. Outliers are observations that are either 3 standard deviations or more above the average, or 3 standard deviations or more below the average. In our second example, we're comparing the admissions records of 2 students, one of whom takes the SAT and the other who takes the ACT. At this particular college, the applicants taking the SAT have a mean of 896 and a standard deviation of 174. And students taking the ACT have a mean of 20.6 and a standard deviation of 5.2. In Part A, John scored 1,080 on the SAT. How many points above the SAT mean did he score? We take 1,080 and we subtract 896. Do the subtraction. This comes out to 184. So John is 184 points above average. In Part B, Susan scored 28 on the ACT. How many points above the ACT mean did she score? So you take Susan's score of 28, subtract the mean for the ACT of 20.6, do the subtraction, and this is 7.4. So Susan scored 7.4 points above average. In Part C, is it reasonable to conclude that John outperformed Susan based on your answers to the previous questions? And with a little bit of thought, I'm pretty sure you can see that the ACT and SAT are on different scales, so it doesn't make sense to compare them in this way. And then in Part D, compute the z-score for John and Susan and then interpret the results. So to compute the z-score for John, we take his score of 1,080, subtract the average of 896, and divide by the standard deviation for the SAT, which is 174. Do the subtraction and the division, and this comes out to be 1.06. Then compute the z-score for Susan. So take Susan's score of 28, subtract the mean for the ACT of 20.6, and divide by the standard deviation on the ACT, which is 5.2. Do the subtraction and the division, and we come out with a z-score of 1.42. So this shows that Susan is the better student, since she is 1.42 standard deviations above the average, where John is only about 1 standard deviation above average.